So what I have discussed in the previous lecture, uh, reflected rays form a image. Clear? When two reflected rays meet, for example, in case of mirror, what we have discussed, when incident rays strike the mirror, then after reflection, image formation takes place when two reflected rays meet. Then image formation takes place like this. In the similar way, in the similar way, when two refracted, you can write when two refracted rays meet, when two refracted rays meet, then image formation takes place. Clear? So there are so
Yes,
many
sir.
application of refraction. One is advanced sunrise, advanced sunset, twinkling of a star. Clear? Size of lemon in a water, it is going to increase. Why? Because of refraction. When you put any pencil in a water, you will see the pencil is little bit raised above. Just do the experiment at your home. You will find that the apparent shift in the position of an object is because of refraction. Clear? Now,
Yes,
this
sir.
derivation is very, very important because so many numericals they are asking nowadays from a refraction topic. Now, see what is apparent depth. Consider this is to be a beaker, any beaker in which some water is filled. Here, and this is any object. Let us suppose our object is any fish or any coin. This is any coin. This is my object, coin. Clear? Now, from this coin, tell me, rays are coming from where? Object. So this is my object, and rays are coming from the object like this. I will draw only two rays. One ray like this. One ray is going like this. So here I will draw the normal like this, and this ray is going away from the normal towards normal.
Towards normal.
False. Air, water. And it is going from denser to rarer medium. So it is away from the
Oh,
normal. Clear?
yes, sir.
Now this is this ray. Do you find any bending here for this? There is no bending because it is incident at normal, normally. So there is no refraction. It will go like this. It is going straight. Clear? Now
Yes, sir.
these two refracted ray. See, this is refracted ray. This is also refracted ray. And these two are the incident ray. And this is the boundary. This is the boundary that separate air and water. Clear? Very, very important relation. This is the boundary that separate two medium. Let us suppose our object is at a height of d or d depth. This object is placed at a depth of d from the interface or a boundary. Boundary can be interface or a boundary. They're same name. Clear? Different name, but meaning is same. Now these two rays, these two reflected rays will not meet anywhere. Clear? So this boundary is acting as a just like a plane surface. Plane surface at which refraction is going to take place. Clear? Now, but these two rays will not meet anywhere. They are diverging rays. Clear? If any observer, listen me carefully. Observer always be where? Observer always be present where our refracted rays or reflected rays are present. So observer will be here. Clear? Now tell me, these two rays are diverging. They never meet. Now, but if you drag this back like this, if you drag it back, it will meet here. Clear? When you drag this refracted rays back, then this will form. And when any two refracted rays meet, not actually, it is appears to meet, then which image is formed? Virtual. Clear? This is the virtual image. This is the real object, and this is the virtual image of real object. Clear? Now, let us suppose the distance of this virtual object from the interface or boundary is d dash. I just take this is d dash. Clear? So d and d dash are measured from the boundary. Let us suppose, just take this is a, take this is a, this is m, this is I, and take this is q. Just I give the name. Clear? Now,
Yes, sir.
in the case of mirror, what we have learned, paraxial rays. Paraxial rays means two rays are closer to principal axis. Rays which are closer to principal axis known as paraxial rays. Now I see your eye, my eye is very small. Since eyes are small, so it always aperture is not that much high. So rays should be paraxial. The rays which will enter in our eye is it paraxial rays. So these rays, if these rays, just see this very carefully. This is the boundary, and if I place any coin here, this is the coin. Now one light is going like this. It is going like this. See this very carefully. And this ray is going like this. See what I am doing very carefully. Very carefully. This point is very important. What I am doing. Again, I am doing the same thing. Did you see one thing? When rays are very close, this is normal rays. And this is the ray in which case our angle of incidence is more. In this case only, here angle of incidence is more. Clear? So when rays are not closer, then angle of incidence is very high. When rays are very close, like this, these two rays, this and this, then in this case, this angle of incidence is very small, then angle of refraction will be small. Clear? So we will neglect this. We will neglect this because observer is looking with his eyes. Since eyes are very small, so we will take only the paraxial rays. Paraxial rays means that is those rays which are closer to principal axis, because in our eye, in our lens, the one lens is there, bulging crystalline lens. That lens aperture is small. So rays which are coming to that lens is paraxial rays. Clear? So write down, since eyes are very important, write down, since eyes are small, Therefore, rays are paraxial. Paraxial, which means angle of incidence and angle of refraction are very small. Already I have discussed this in case of mirror. Is it clear?
Yes, sir.
Now see this very carefully. These two rays are very close. These two rays are very close. But I have shown little bit far. So don't confuse. Just for your understanding, I'm showing like this. These two rays. One ray, this is one ray. This is next ray. These two rays are paraxial. Clear? Now, see, this is angle of incidence I. This is angle of incidence I. This is angle of refraction. Clear? Now, I will draw this diagram here. I will draw this diagram here. See it very carefully. This is the boundary. And this is going like this. When you drag it back, it is coming here. This is Q. This is M. This is A. This is, I just take this is I. Clear? Tell me, if this is angle of incidence I, then this is also angle of incidence I. Because these two are parallel. Understood? See, this is parallel to this. Then this is I, then this is I. Understood?
Yes, sir.
If this is R, if this is R, then can I say this is R?
Yes, sir.
Corresponding angles are equal. This is parallel to this. Like this Z formation. You have learned this Z. This is I, this is also I.
Yes, sir.
This is parallel to
Alternating.
this. Then Z, always see Z like this. This is parallel to this. Then these alternate angles are equal. And this is the corresponding angles. Clear? Now, here in this derivation, see this, if I apply the Snell's law, if I apply this is I, then this is also I. You should draw, okay? You should write this is also I. If this is R, then this angle is also R. Clear? I have shown here. Let us suppose just take this distance is X. This MI. This MI is X. Clear? Now apply Snell's law. Apply Snell's law and tell me what should I write? Apply Snell's law. Then what is Snell's law? Mu into sine theta is constant. Clear? This is Snell's law. Now boundary. This is the boundary. Here water. Here, or you can say this is first medium and this is second medium. Always take one where our object or light is coming. So light is coming from where object. Then take that medium to be 1. Clear? Now light is going in another medium. It may be XYZ medium. Always take that to be 2. Clear? So refracted index of this medium is mu1 and the refracted index of this medium is mu2. Clear? Now apply the Snell's law. Mu1 sine of theta. How much? Sine I. First medium you have applied Snell's law. It is equal to. Apply the same in second medium. Mu2 sine R. Are you understanding like how am I applying the Snell's law?
Yes, sir.
Okay, then it's good. Equation 1. Clear? Now when this I and R is very, very small, so I can say sine I, if I is very small, then sine I is approximately equal to I, which is approximately equal to, can I say all are equal? Mathematics, just you should remember these things. Tan I. Clear? Similar way, sine R. Sine R is approximately equal to R, and I can say 10 of R. Clear?
Yes, sir.
Any doubt? Now
No doubt.
mu1 sin I can write mu1 tan I equal to mu2 tan R. Now from this triangle, tell me what is tan I? What is tan I? See this triangle. See this triangle MIA. MIA. This is I. X and this is D. So tan I will be, what is tan theta? Tan theta is perpendicular by base. So tan I, theta is I in this triangle. What is perpendicular? Tell
D
me.
by X.
Perpendicular. This is perpendicular by base. In this triangle, what is perpendicular? This is 90. Tell me.
Sir, D is perpendicular.
No. D, what is the meaning of perpendicular? If I am writing tan I, angle is I. The side opposite to angle is perpendicular. Clear? Don't worry, I will arrange one trigonometry classes. Later you will understand, or I will take. No worry. Clear? So as per this triangle, this tan I will be perpendicular upon base. This AI. This AI is perpendicular. So I can write this X. Base. Base is side opposite to 90-degree hypotenuse. This is hypotenuse, and whatever remaining is base. AM. So it will be X by T. In the similar way, see this triangle MQI. 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 I will draw here MQI. See, this is R, and this is what? T dash, and this is X. Then tan R will be how much? Tan R, tell me how much tan R?
X, X by D. D dash.
Very nice. X by T dash. Now put this value here. Tan I is how much? X by
By D.
mu2 tan R. R
X
is
by
how
D
much?
dash.
How much? X by T dash. Now see this very, very carefully. X cancel out. Then what you got? D dash by D equal to mu2 by mu1. Very, very important relation. And what is D dash? D dash is apparent depth.
Then
You can write apparent depth of an object measured from the boundary or interface. Clear? In the similar way, what is D? D is the real depth of an object measured from measured from interface. Clear? What is mu1? Mu1 is the refractive index of a medium. Refractive index of a medium from which light, you can write refractive index of a medium from which light is coming. From which light is coming, or simply refractive index of a medium from which light is coming from object. Clear? What is, wherever object is present, you just take mu1. Clear? mu1 means refractive index of medium where object is placed. What is mu2? Similar way, refractive index of a medium in which light entered. Clear? Now
Yes, sir.
this formula is valid for one interface. For example, one interface, one object is placed. If object is placed like this, again I am showing here, then how, what is the meaning of this? You will draw two lines like this. This is one ray from this object. This is one more ray. Clear? This is I, this is R, and when you drag it back, then you will get, this is the image. Clear? When, see, these two rays are not meeting anywhere. These are diverging rays. When you move it back, it actually meet. Not actually meet, it appears to meet. This is the, see what is, this is known as real depth, D. Apparent depth is, this is apparent depth, D dash. You will measure all the distance. You will do measurement from where? Interface or boundary. This is interface or boundary. Clear? So this formula is valid for one interface and meaning is clear. Tell me. Now
Yes,
observer
sir.
will
It's
be
clear.
where? Observer always present where is our interface, not interface where is reflected rays are going. See, observer will be here because reflected rays are present here only. So light is coming from this medium, then take one. Second medium, two. Is it clear? Now if I ask
Yes,
you,
sir.
if I ask, what is d dash by d? How much?
Mu 2
1.
by mu 1.
Mu2 by mu1. Then d dash is how much? Mu2
Mu
by
2 by mu
mu1.
1 into D.
Clear? Now if I ask, shift, normal shift. Normal shift. I can say delta. You can write delta S. How much shift? Initially object is D. Clear? Now finally it is going where? D dash. Clear? Then
Yes, sir.
if it is positive, see if the value is coming out to be positive, then you will take what? Final minus initial. Always take final minus initial or initial minus final, whatever you want to take. Clear? Is it
Yes,
clear?
sir.
Tell me this derivation is clear. If they are
Yes, sir.
asking
It's
what is
clear.
the meaning of first shift, can you calculate?
Yes, sir.
Okay, just write one question. Just will give one question to you. Shift formula you can write how much? D minus D dash. This is the shift. Clear? Now
Yes, sir.
in our case, which one is more?
D is more.
D is more. Since D is greater than D dash, then delta S is positive, negative.
Positive.
Positive means it will shift where? Object. Because this image is of an object. Clear? Surface is plane. So plane surface acting as a plane mirror like that. Understood? So it will shift in the direction of in the direction of incident ray. Clear?
Yes, sir.
Incident ray is going from object to like this. It is incident rays are going like this. So it will shift in that direction. Clear? If delta S is negative, delta S is D minus D dash. If it comes out to be negative, it means it will shift in the opposite direction of incident ray. Is it clear? Any doubt?
Yes, sir.
I can explain.
No doubt, sir.
What is the meaning of this? Why negative? I can give one example. Let's see. This object is placed in denser medium here. But if this object is placed like this, if object is here, clear? If object is here, I will share one more link. Clear? Just a minute. But see up to which it is going on. From this object, you will draw two rays like this. Like this. One. I have drawn. Let us suppose this is mu1 and mu2. Then mu1 is more than mu2. Mu1 is more than mu2. Now what is the meaning of real depth? This is the real depth of this object from the interface. That is D. Next ray you will draw like this. It's going like this. Now this ray, since mu1 is more than mu2, then which one is rarer, which one is denser? Tell me.
Mu1 is rarer, mu2 is denser.
Mu1 is, tell me,
Rarer.
mu1 is rarer, wrong. Mu1 is more than mu2 means what? In which case speed is
Then
less.
it's denser.
See, you
And
can
mu1 is
see by
denser
V2.
and mu2 is
V2 is greater than V1. The medium in which speed is more is rarer. Medium in which speed is less is denser. So this is denser. This is rarer. Clear? So it
Rarer.
is going from denser to rarer. So it is going like this. When you drag it back, you will see this is O dash or a virtual image. Then this is D dash. Then shift will be positive, negative. Tell me,
Mm,
it is shifting like this in the direction of incident ray. Incident ray is going like this, and it is shifting from O to O dash
positive. Positive.
and positive. See the shifting. If you solve also, just write the formula. D minus D dash. What is the formula? What is the formula? Simply apply the D minus D dash formula. In case of positive shift, our D is more than D dash. Clear? But if I take,
Yes.
for example, if mu1 is less than mu2, first case I take mu1 is more than mu2. But if I take like this, if I draw, let me draw this like this. Rays is going. This is the object. Two rays are going like this. Now in this case, this is mu1, this is mu2. But I just take this is mu1 is less than mu2. Then which one is more denser? Which one is rarer?
Mu2 is denser.
Mu2 is denser. Now light
Mu1
is
is rarer.
going from
Mu2 is
rarer to
denser.
denser. Clear? Then in which direction it will bend? Like this.
Towards normal.
When you drag it back, it is coming from here. O dash will be here. This is D. And this is D dash. Then which one? Delta S will be what? D minus D dash. Is it positive, negative? Tell me.
Negative.
Very good. That is why it
Negative.
is shifting in the opposite direction of incident ray. Our incident ray is like this. It is going to shift like this. O say O dash. O to O dash. Clear? Any doubt? So shifting delta is positive
No
means
doubt, sir.
shifting positive means our object will shift in the direction of incident ray. Shifting negative means our object will shift in the direction opposite to the incident ray. Is it clear? Any doubt?
Yes. No doubts.
Okay. So I will share one more link. Then in that link I will discuss some numericals. Okay. Is this point is clear? Shift
Yes, sir. Yes, sir.
Shifting for one surface, one boundary is very simple. D minus D dash, real minus apparent. Clear? So because of refraction, this phenomena is happening. Clear? Any doubt? Now tell
Yes,
me,
sir.
observer. All observer will be here because these rays
No
are
doubts.
entered in the eye of observer. Clear? Observer will be always where? Where is our observer? It always be available in the refracted ray region. Clear? So in the eye of observer always either
Yes, sir.
reflected ray will enter or refracted ray. Reflected ray in case of reflection, refracted ray in case of refraction. Any doubt?
No doubts, sir.
Okay, I will share one more link. You just join from that. Okay. Okay, wait.
Yes, sir.
Write down the question. Find the apparent depth. Find the apparent depth of fish as seen by bird. So I will draw the diagram. Just see this carefully. I will solve. Don't worry. But you must be very, very careful. Clear?
Yes, sir.
So this is any pond. Clear? Here bird is flying. And this is any fish. So inside pond some fishes are present. Fish. So uh, actual height is what? Fish actual height is 24 centimeter. And bird is having how much? 36. Now refractive index of this water is 4 by 3. Refractive index of air is 1. Now in this question they are asking find the apparent depth of fish as seen by the bird. Now who is object, who is observer? Who is looking the bird, fish? Tell me. We are asking apparent
Bird is
depth of
observer and
fish. Fish
fish
is
is object.
object. And which one is observer? Bird.
Bird is observer.
So as per this observer, what is the apparent depth of fish as seen by the bird? Clear? Now this question, this word statement is very, very important. Here our observer is little bit far away from the boundary. So they are asking the distance from the observer. Now first of all tell me according to this observer, this is denser, this is rarer. Simply tell me, apply the formula d dash by d is equal to mu 2 by mu 1. Is it the
New
same
one.
formula? Check.
Yes, sir.
D dash by d. So the d dash is apparent depth by real depth. Real depth is 24. Mu 2 means the medium in which our light is going to enter from the object. Now I'm not drawing, like you should be very, very careful. Light is coming from the object like this. I'm not going to draw. Already we have completed the derivation. You should know. But I will provide some ray diagram also in the later question. This question is easy. That's why I'm not showing. Clear? But you can draw. If you wish, you can draw. So mu 2 is 1. Mu 1 is how much? 4 by 3. So d dash comes out to be 3 by 4 multiply 24. What is the answer?
18.
So this fish, which is which will what is the apparent depth of fish? 18
18
centimeter. This
centimeters.
is fish is 18 centimeter from where? From the boundary. Clear? Because d and d dash measured from the boundary. Then what is the apparent depth? Apparent depth of fish as seen by word. Tell me the answer.
So 54, sir.
Very good. 18 plus 36. How much? 54. Now, same question I am asking, but now in this question, just you will give me the answer. Write down the question, next question. Find the apparent depth of bird as seen by fish. What is the answer?
1
Same
minute, sir.
question. Now fish is looking the bird. Give me the answer. If nothing is given, always take air. Clear?
Yes, yes.
Solve this. Apparent height of question is
Sir,
not for.
apparent
See,
height is 48, and as seen by fish, it is
see, this is for word we will use height because bird is some height. It is not depth because bird is not inside the water. So correct English is find the apparent height of bird as seen by the fish. What is the answer?
as the apparent depth of the bird is 48 centimeter, but as seen by the fish is 24.
Okay, let me solve. D dash by D equal to mu2 by. Now what is D dash? Apparent depth. We need to calculate. D is how much? Of bird as seen by who is observer?
Fish is the observer.
Object is bird. What is the real depth? 36
30,
for bird. Mu2 by B1. Now which one is mu2?
4.3,
D dash
48.
comes out to be. Then what is the answer apparent depth? 72
Sir,
centimeter.
I have a
Clear?
doubt, sir.
Yes, tell me.
Sir, I'm getting confused like where to add and where to subtract.
No need to subtract. Distance. Distance never subtract. Now tell me this 48 means what? According to this fish, this bird is not here. This bird is here. 48. Clear? You should draw. Otherwise, you will be confused. If you want to draw, you can. Now, in this question, why is it 48 is above? Because now observer is in rarer medium and observer in denser medium, our object is in rarer medium. That is why it is always, always it will be a positive shift. Sorry, negative shift. D minus D dash. 36 minus 48 always be negative. So it always shift like this. Clear? If anybody is
Yes,
asking
sir.
what is the shift, then for 36 minus 48. Yes, tell me. Then if it is 48, now they are asking what is the apparent depth from the fish. From the fish, then you will add or 28 plus 48. If they are asking simply find the apparent depth, then in that case, simply answer is 48. But they are asking as
Yes,
seen by fish. So
72.
72. But if they are asking find the apparent height of bird, if they are not writing as seen by fish, if they are not writing like this, they are asking find the apparent height of bird, then bird is object.
Then only 48.
Yeah, 48. But if they are saying as seen by the fish, then according to fish, if nothing is given, we will take this where we will not take care of this 24. We will not add. If they are saying as seen by the fish, then we will take care because our observer is not at interface. Clear? In
Yes,
most
sir.
of the question, they will mention where is our observer. If nothing is given, observer will be where is our refracted rays going. Clear? If you want to draw, you
Yes,
can
sir.
draw. Let me draw. You see, this is fish in first case. Fish is here. And this is the bird which is looking. This is the observer. And this is the object. Now tell me, one ray is going like this from this fish. Denser to rarer. Denser, water to air. Will go like this. Now shift will be, fish will be here. Clear? Any doubt? Fish will be here. This is d dash.
No doubt.
And already you have solved. This d dash is how much in the previous question? This d dash is how much? Tell me.
For
18.
fish, it's 18.
And this d is what? 24. And if you calculate shift d minus d dash, comes out to be positive, negative.
Positive.
Positive means this fish will move in the direction of incident ray. See this incident ray. This is the incident ray. The ray which is coming from the object is incident ray and is striking the boundary. So our object is shifting like this in the direction of incident ray. This arrow sign. See, this fish is going up. It is shifting in the direction of incident ray. Why? Because our shift is positive. Always calculate shift. If shift is going to be negative, then it is going back. If you do not want to draw any ray diagram, if you do not want any ray diagram, then always calculate the shift. Clear? Otherwise, draw the ray diagram. Now in the next phase, let's see. Here bird, here fish. Like this. Now, just see here. Here our observer is. Who is the observer?
Fish is the observer.
And this is the object. Now object, light is coming from the object like this. One light is coming like this. Let me draw again. One normal ray like this. And one ray is going like this. Now tell me, this is air, this is water. Light is going from rarer to denser medium. Now in which direction it will bend? Towards
Towards
normal,
normal.
like this. Clear? Now when you drag it back, this bird will be where? This bird will not be here. This is the virtual image of this bird. Here. That is virtual image of the bird, which is seen by the fish. Now fish is looking this or this? This one.
The virtual image.
Virtual image. So fish, according to the fish, this is d dash. How much? You solve? Tell me.
Yes. According to the fish, it is 72.
70. Oh, no, total you are telling. How much this? 36?
48. 48. It's
48.
48.
Now, if this is, see, this is the apparent height, simply. But they're asking as seen by the fish. So, according to fish, fish is where? Fish is also at certain height. Fish is also at a certain height. 24, then we will add. But if they're asking simply what is the apparent height, then simply answer is 48. But if they're asking apparent height as seen by the fish, then always add 48 plus 24. Is it right?
Yes, sir. 24. Then we'll get the
Now here,
72.
see, in this question shift, delta is how much? D minus D dash. D is how much? Actually bird is at a height of
36 centimeters.
minus apparent height. 48 is coming out to be negative and we already draw the ray diagram. If you don't know ray diagram, then always calculate shift. Then delta S is negative means it is going to shift. Can you see? It is going to shift in the opposite direction of incident ray. This arrow diagram is what? It is showing this bird is going to shift like this. Incident ray is going like this. And bird is going to shift like this. Any doubt?
Not also.
So I will stop this lecture today. Take care of yourself. Eat well, sleep well, and don't take any food outside. Clear?
Yes,
Tomorrow
sir.
also I will solve some numericals or sidely you can, this topic is very important. Lens theory, like when I started the lens chapter, then you will realize this the importance and weightage of this chapter in JEE NEET competition. Clear? So make sure understand this topic very in depth. Once you get a mastery in these topics like this, which I'm teaching now, you can solve any numerical. And optics, electricity, and magnetism. These are the three chapters having 60% weightage in your JEE NEET preparation. Clear? So make sure, don't worry. Slowly, I will tackle all the problems, all the concept. But make sure, don't be in hurry. Don't be in a hurry. It will take time. It will take time. Once you get a mastery, you can do any question, any tough question easily. Clear? So I will touch electricity maybe after this month. I will take this entire month. But I will make sure you can solve any physics, any question from optics. So this foundation lectures are very important. You are learning in such depth. You can solve any question from apparent depth, and many questions they are asking. Up to foundation level, I will teach all the things. But if you go, optics is not this. This is not the end of optics. It is more, too much. When you reach in class 12th, there that time you will study only 20-30%. 60% optics I will teach. Don't worry. Basics. If you get a mastery in basics, these basics of optics, you can solve any numerical. Clear? So you should be very confident whatever you are learning here. So focus, practice well, revise the notes again and again. Try to revise. Revision is a key for success in any exam. If you do not revise, because our mind habit is to revise. Once you revise daily, in morning try to revise the notes and try to solve the same numericals which I already solved in the class. Try to solve again and try to solve some new numericals. And I will check your PDF answer key. I will check. Don't worry. Clear? So take rest.
Yes.
So good night. Any doubt? Tell me today's lecture.
No doubts.
Keep a smile always. Clear? Take care of your
Yes, sir.
health. Okay. Tomorrow, if you wish, 7 o'clock. Okay, no worry. I will encourage class by 7.
No, sir. Tomorrow I'll be better.
Better na?
5, sir.
Okay. Please take care of yourself and don't eat outside food. Okay.
Hmm.
Okay. Thank you. Good night.
Thank you, sir. Good night.
Yeah.